Hey guys, so we're going to do another problem from the review. Let's go ahead and do number 5. It says we'll switch colors here. It says to graph the function y is equal to negative tangent. Oh, no. Am I doing the right one? Yeah, I'm doing the right one. Negative tangent of 2x. Okay, so what I want to do is first I want to make myself a unit circle. Okay, the thing I've been griping at you guys about from day one. Okay, so this is 1, 0, this is 0, 1, this is negative 1, 0, and 0, negative 1. Okay, and then I want to make myself a table. So, got my x and my y. So, I should know all of the angle measures off the top of my head in radians. So I know I want to start with 0 and go pi over 2. Then pi, then 3 pi over 2, and 2 pi. And if you remember, tangent was one of those special ones where we had to have something called the test point. So I'm going to go ahead and I'm going to include the test point. And the test point we used was always pi over 4. And the reason is because the tangent of pi over 4 has a really nice output. It's 1, which makes that really easy for any calculations that we need to do. So now that we've established that, we want to go ahead and figure out what all of the y coordinates or the outputs of our function are going to be at all of these locations. So at 0, tangent, and this is just in standard form, okay? At 0, tangent, which tangent is y over x, okay? So if I take my y value over my x value, that's 0 over 1, which is 0, okay? Now, going up to pi over 2, or 90 degrees, I do the same thing. Y over x gives me 1 over 0. This gives me undefined, okay? And I'm going to notice that there's a repeating pattern as I go down until I get over here to pi over 4, which we already figured out, we already know is 1, okay? So this is my standard form of the tangent function. This is just tangent of x. This doesn't account for the transformations, and we have a couple of transformations in here. Those transformations are a flip over the x and a horizontal shrink of 1/2. So what we want to do is go ahead and make those transformations appear in our table, or reflect them in our table. So this flip over the x is actually going to change the sign of all of our y values, okay? So we want to multiply this, everything in this column, by negative 1. Now that's not going to make a whole lot of a difference, because obviously multiplying zeros and asymptotes isn't going to do anything. What matters is when we get down to this test point down here. He's now going to have a value of negative 1, so he's going to change, but he's going to be the only thing that changes, okay? So actually I'm going to erase this. And I'm going to just write negative 1, and I'll do it in a different color so we know that, so that we know he's changed. So negative, really? You guys. Red. You guys have no idea how hard this is to do it on my tablet. Okay, so the test point is now negative 1. So that is our that's our flip over the x. So now we want to do this horizontal shrink of 1/2, okay? So we basically want to take our horizontal axis, or our x, and we want to multiply everything by 1/2, or divide by 2, whatever you want to look at it as, okay? So this guy becomes pi over 4. This guy becomes pi over 2. This guy becomes 3 pi over 4, right? Is that what I said? Yeah, 4. And our 2 pi is just going to become pi. Okay, now we do have to make that same transformation to our test point. So pi over 4 now becomes pi over 8, because 4 times 2 is 8. So my table's good. I'm ready to plot all my points. Oh, and 0. He hasn't changed, in case you were wondering. Okay, so let's plot what we know. So here's my axis. Okay, and I'm going to just mark all my tick marks. There's 5 of them I should have. So 0, and then, 5 tick marks, because we have a test point. 1, 2, 3. Actually, I'm going to space those out a little bit more. Try 1, 2, 3, and then 4. Much better. And then our test point's going to be right there. So this is our pi over 8. And then this is backtracking. So this is my pi over 4. Remember, because my period is pi. So if I cut it into 4 pieces, each one should be a multiple of 4. So this is pi over 4, 2 pi over 4, or pi over 2, and then 3 pi over 4. Okay, and then pi over 8 is obviously half of pi over 4. So now I want to just, again, plot what I know. So at 0, I have a 0. That hasn't changed. Oops. At Pi over 2, I also have a 0. So pi over 2, I want to put a 0. I also have a 0 at what's pi now. So, okay, there we go. So those are my 3 zeros. Now I want to plot the asymptotes. So we'll do those in a different color just so we can see them clearly. So the asymptotes are at pi over 4 and 3 pi over 4. Again, this is after it's been transformed. So, and then my test point has a location down here at -1. So pi over 8, we're going to go down -1. So he's right there. Okay? Oops. So a lot of you have trouble figuring out which direction the graph should be going. So let's talk about that real quick here. So I'm going to erase this table if it's okay, just so I can kind of have some space. You guys should, of course, have this in your notes already, so you don't need it. Okay, so in order to figure out where this graph is going to be positive and where it's going to be negative, or in other words, which direction it's going to be going, we want to take a look at the sign of our trig function in each of our 4 quadrants. So up here in quadrant 1, this is quadrant 1, both x and y are positive. So I have positive, positive. Quadrant 2, one of them is negative, which is x, and one of them is positive. Okay, and we can kind of fill these in like this, negative, positive. Okay, so now again, using this information and then going back to my original tangent function here, if I know that tangent is y over x, okay, and I know that in quadrant 1, both y and x are positive, what do I expect the function tangent to be? Well, I expect him to be positive. If both of his parts are positive, I would think that the function overall would be positive. So what we would expect is we would expect that between 0 and pi over 2, or our first quadrant marking, okay, this first chunk of the graph, we would expect it to be somewhere up here in the positive range, right? Okay, so why isn't our graph up there? Why is our point down there? Well, we had a transformation, right? We had to flip over the x, which means our graph is now going to be down here, okay? So you kind of got to think about it in terms of where's it going to be in standard position, and now where's it going to be after there's been that transformation. So let me get rid of some of these dots here. Okay, so I know my function starts at 0, that was on my table, and I know it's going to go through this point, and I know I want it to stay in the bottom half of my graph. I want it to stay in the negative region, so it's basically just going to go down, and it's always going to approach the asymptote like that. Okay. Now, the tricky part is, what do you do from there? Because now you don't have any more test points, right? So pi over 4 and pi over 2, if you remember before we transformed them, these used to be pi over 2 and pi, right? So basically, between pi over 2 and pi, well, that's quadrant 2, right? So basically what this section here represents is what's happening when the function passes through quadrant 2, okay? So if I take a look at the signs of everything in quadrant 2, I have x's are negative, y's are positive. So the ratio y over x is going to be positive over negative, which gives me a negative, right? Which again tells me my graph should be down here, but oh, what's the problem? Well, the problem is that we had a transformation that caused him to flip and go to the other side. So we need to make our graph somewhere up here, okay? So we know that it's going to be on the positive half of the graph. We also know that we have a 0 at this point. We again also know that we should approach our asymptote at all costs. So our graph is going to look like this. It's positive, it's approaching the asymptote, and it goes to that point that we already established. And then from there, you should be able to kind of see the pattern. Okay, now it's going to go down. Okay, here it's going to go up again, and it's going to just have that same repeating pattern as you go on and on. Okay, so that is the answer for number 5.